This is a problem from your assignment, from the Isosceles Triangle assignment. It says that DC, right here, let me get a pen here. I don't have a pen. DC is parallel, so I'm going to mark it with an arrow here, to AB. That's what it says. This angle here is 24 degrees. This angle here is equal to that angle there. And I want to find, ultimately, this angle right here, angle BOC. Okay. I don't have a clue how I'm going to do that, but we'll give it a shot. This uses a lot of information, a lot of things we've learned along the way, brings them all together in one problem, and that makes the problem extremely hard. But if you notice everything along the way, it'll be good. And notice also this is on the isosceles triangle problem, or we did all these isosceles triangles. And in working these problems with isosceles triangles, we know that if two sides are equal on a triangle, then it's an isosceles triangle. Well, I'm going to say that I think BO and CO are equal, and I'm going to mark them. And the reason I'd say they're equal is this is a circle. Here's the center of the circle, and the distance from the center of the circle to any point on the circle is the same. So I have an isosceles triangle. And what we did with isosceles triangle today, we noticed that if you have a base angle, so there's that angle, would have to be the same thing as that angle. And lucky for us, is also the same thing as that angle right there. So all three of these angles are the same. And the reason I have this one over here is because it's an isosceles triangle. Okay. Now the next thing I have is I haven't used this idea about parallel. So I'm going to extend my lines out here, parallel lines. And this could be my transversal, so I'm going to mark that one up here, and I'm just going to color over it here so I know that that's my transversal. So when I have parallel lines, I have alternate interior, so that those would be alternate interior, right? Is that right? So that big angle right there is alternate interior to this big angle over here. But I'm not really interested in alternate interior angles or corresponding angles. What I am interested in is that this angle right here on this side and this angle right here on this side, well, I'd like to relate those two angles. And isn't it true that if angles are on the same side, that this angle plus that angle would give me 180 degrees? And I don't know about you, but whenever I run into myself into a hole here or into something, and I want to find the length of these, measure of these angles, I don't know. I don't know what they are, but they're all the same. So I could refer to them all as, say, x. And I'll call this one x and this one x. So this angle up here, this big angle, would just be 24 plus x. And this other angle right here is just x plus x, which would be 2x's, right? 2x's. And since they're on the same side of the transversal, and I have my parallel lines there, well, they have to add to 180 degrees. Well, let's see if that helps me out here. I have 24 plus 3x equals 180. Okay, well, 180 take away 20 would be 160. Take away the 4 more, and I have 156 equals 3x. A real neat thing is if I add 1 plus 5, I get 6, plus 6 is 12. 12 is divisible by 3, so is that. So I'm going to divide by 3. 3 goes into 15 5 times, and 3 goes into 6 2. So I guess x is 52. But that's not what I'm trying to find. I know that this angle here is 52. This angle here is 52. And I really want to find this angle right here. Okay, well, that's 104. And I know that all triangles, all three angles must add to 180. So 6, 8, 7. Well, 76 degrees. Well, what made it hard is that you had to use quite a bit of the information. Isosceles triangles, base angles are the same. You have parallel lines, so angles on the same side there would make 180 degrees. All that work just to get these two base angles, and that's 76 degrees. Well, there you go. Fun, huh?